1.
Hi, my name is Aniq and I'm Jovan. Welcome to the Physics Go. Today we're gonna learn about speed and acceleration.
Now we are going to compare Aniq, which is moving at constant speed, to Jovan, which is accelerating from rest. Jovan lets Aniq get to the middle of the screen, and only then does he start accelerating. Aniq is represented by the blue line on the graphs, while Jovan is represented by the red line. Let's take a look at the distance time graph first, the one at the top. You can see that the blue line, which is Aniq moving at constant speed, the line is straight and diagonal, and the gradient is constant. However, for Jovan, the line curves upwards immediately after the 16-second mark, when he starts running. The curve becomes steeper and steeper, which means the gradient becomes bigger and bigger. As the gradient of a distance time graph is the speed, this shows that the speed is increasing. This is confirmed when we look at the speed time graph shown in the middle. Jovan's speed increases sharply from 0 at the 16-second mark, and then it increases and slowly keeps increasing until the end. And then, looking at the acceleration time graph at the bottom, you can see that Jovan's acceleration is not 0 throughout, like Aniq's. Instead, there is a jump in acceleration starting from the 16-second mark, which continues to remain above 0 as Jovan continues to increase his speed. Let's take a look at a different scenario when Aniq is going at a constant fast speed on the scooter, while Jovan once again accelerates from rest. This time, Jovan starts accelerating as soon as he sees Aniq pass him in the scooter. At the end of the video, Jovan just manages to catch up to Aniq. So you can see on the distance time graph at the top that the start points and the end points of both the red and the blue lines are roughly the same. On the speed time graph, you can see that Aniq maintains his constant speed. However, Jovan's speed is slower than Aniq at the start, reaches Aniq's speed in the middle, and surpasses Aniq's speed in the end. The gradient of the speed time graph is the acceleration. For Jovan, the gradient at 0 to 4 seconds seems to be steeper than the gradient from 4 to 13 seconds. Therefore, the acceleration should be greater from 0 to 4 seconds than 4 to 13 seconds. This is confirmed when you look at the bottom graph, the acceleration time graph. From 0 to 4 seconds, the acceleration is definitely higher than from 4 to 13 seconds. Now, we are going to compare the uniform acceleration of the scooter compared to the non-uniform acceleration of Jovan running. Let's look at the speed time graph in the middle. The red line, which represents Aniq, is a nice straight diagonal line. As the gradient of the speed time graph is constant, this implies that the acceleration should be constant as well. This is confirmed by looking at the acceleration time graph below, where the red line, even though it's slightly jagged, generally indicates a constant acceleration. Now, let's take a look at the blue line on the speed time graph, the one in the middle. From 0 to 8 seconds, the gradient of the graph gently curves upwards. This means that the acceleration is increasing. From 0 to 8 seconds, if you look at the acceleration time graph, it is quite clear that the acceleration is increasing sharply to a point. This corroborates what we see on the speed time graph. Now, if we look at the speed time graph from 8 seconds to 20 seconds, you will see that the speed is still increasing, but the gradient is decreasing. This means that the acceleration is decreasing from 8 seconds to 20 seconds. When we look at the acceleration time graph, we see that the data actually matches as well.
Thank you for watching. Hope you enjoyed the show.